Okay, organic halides. They are also known as alkyl halide or aryl halide. Alkyl halide are also known as haloalkanes. So the halo here are representing the halogens, and it could be fluorine, chlorine, bromine, and iodine. It will have a general formula of Rx, wherein R represents series of carbon atom. So, mga series of carbon atom yan. And the halogen are fluorine, chlorine, bromine, and iodine. For naming fluorine, you're going to name it as fluoro. So, this is fluoro. Take note of the spelling, Fluoro. Okay? And then for chlorine is chloro. Bromine is bromo. Okay. And iodine is iodo. Iodo. So that's how you're going to name them. Aryl halides, for on the other hand, will have a formula of ARX, wherein AR represents the aromatic ring, benzene ring. Okay. So the characteristics of this organic halide is dependent on the halogen, okay, where the reaction takes place. And the functional group for these organic halides is eventually the halogen. So that's the functional group. For the classification, we have three, and it is primary, okay, secondary, and the last classification is tertiary halide, tertiary alkyl halide. Okay. How are we going to classify it as primary? You have, the structure should have halogen being bonded to a primary carbon atom. So, ang unang titignan natin is the halogen. Look for the halogen. And then afterwards, tignan natin kung saan siya naka-attach sa carbon atom. Dapat ay primary carbon atom. Paano magiging primary carbon atom? This carbon atom should only be bonded to one carbon atom. So, isa lang. And the rest would be hydrogen. Okay, so ulitin natin. This ethyl chloride, or having an IUPAC name 1-chloroethane, is classified as primary alkyl halide. Kasi reference natin, tingnan natin yung halogen. Naka-attach siya sa carbon atom na ito. At yung carbon atom na yan, iisa lang yung carbon atom na naka-attach sa kanya. That makes it primary. The rest are hydrogen. Okay? For that to be secondary, the halogen is bonded to a secondary carbon atom. For it to become a secondary, that carbon atom should be bonded to two other carbon atoms. So, secondary, for example, is 2-chloropropane. So, this is the chlorine. That's the halogen. It is bonded to this carbon atom. That carbon atom is secondary carbon atom because it is bonded to two other carbon atom. So, this time, isa na lang yung hydrogen niya. Okay? So, for it to become a tertiary alkyl halide, still, it will have a halogen atom being bonded to a tertiary carbon atom. For it to become a tertiary carbon atom, it should be bonded to three other carbon atom. So, reference pa rin natin is the halogen. It is bonded to a tertiary carbon atom. That tertiary carbon atom should have other three carbon atoms being attached to it. So, an example of this is 2-chloro 2-methylpropane. So this is the halogen. It is attached to this tertiary carbon atom. The tertiary carbon atom is bonded to three other carbon atoms. So that makes it tertiary. Now for the nomenclature of organic halides, we have two types. It could either be common name and IUPAC. But take note that for common name, this is only applicable for simple alkyl, and it would be composed of two words usually. It's the name of the alkyl plus the name of the halide. So ulitin natin, this is only for simple alkyl. For the IUPAC, so we are using the prefix fluoro, chloro, bromo, or iodo, and then we have the position numbers. Always, the numbering system should come up with the smallest set of number. Okay, so for this example, the parent chain will have 4 carbon atom in a single bond. That's why it has butane. It is numbered from right to left, because even if it is numbered from left to right, the first encountered substituent would be 2 and 3. However, from right to left, 2 and 3 then. Okay. However, for this case, since we have equidistant numbering, we are going to have the alphabetical listing or alphabetizing as a tiebreaker kung saan tayo mag-uumpisa. Kasi parehas na 2 and 3, left to right, right to left. So since bromo came first, then iodo, so we are going to number it from right to left. Having bromo on the second and iodo on the third. So therefore, this is 2 bromo, 3 iodobutane. For aryl halides, okay, so we are going to number the benzene ring clockwise or counterclockwise. However, as you could see, we have two substituents here, the methyl group and the bromine group. However, the methyl group has a priority over the halogen, so therefore it will have the special name of toluene rather than as methylbenzene. So hindi methylbenzene, rather the special name toluene will be used. And since methyl has a priority over the bromo, so the methyl will have on carbon number 1. And numbering it clockwise or counterclockwise, we're going to have bromine being attached on carbon number 4. So therefore, this is 4-bromotoluene. Still, the use of dash and no space is being followed. Okay. Then we also have, so this is N-butyl bromide. This is actually the common name. And then 1-bromobutane is the IUPAC name. Okay, so for the common name, you are naming first the alkyl group, butyl. This should be propyl. Butyl should have 4 carbon atoms. So therefore, for this to be butyl, there should be, okay, there should be 4 carbon atoms there. And then 1-bromobutane. We need a number here because to denote that the position of the bromine being attached to carbon number 1. Okay, then we also have isobutyl chloride. So the whole of this is isobutyl, and this is the chloride. Take note, for the common name, we have two words. However, for the IUPAC name, we only have one long word. And this one is 1-chloro 2-methyl propane. It is a propane because the longest chain of carbon atom for the parent chain is 3. So that's prop. This is carbon 1, that's carbon number 2. So that chlorine is attached to first carbon atom and the methyl group is attached on the second carbon atom. Okay, another example would be 2-iodo 2-methyl butane. Butane because there are 4 carbon atoms in the parent chain. It is numbered from right to left, being that to be carbon number 2, wherein the iodine is being attached, so that's 2-iodo, and then this is the methyl group still being attached to the second carbon atom, so we have 2-methyl butane. The classification is tertiary because reference is the iodine. It is being attached to this carbon atom. However, that carbon atom has been attached with other 3 carbon atoms, so that makes it tertiary. For the next example, the parent chain has 5 carbon atoms. The first encountered substituent would be on carbon number, this is carbon number 2, and this is carbon number 3. Numbering system is from right to left. The chlorine is attached on the third carbon atom, and then this methyl group is attached on the second carbon atom. That's why it is 3-chloro 2-methyl pentane. The classification is secondary because reference is the halogen being attached to this carbon atom, and that carbon atom has 2 other neighbor carbon atoms, so therefore that's secondary. Okay. The next is 4-bromo 2,4-dimethylhexane. So we have this as a parent chain. It has 6 carbon atoms, so that's hexane. It is numbered from right to left. So this is carbon number 2 and this is carbon number 4. Okay. On that carbon number 2, we have CH3, and on carbon number 4, we have also CH3. So these two are methyl. We are using di to denote that there are 2, and they are on the second and on the fourth carbon atom. On the fourth carbon atom as well, we have bromine, so that's 4-bromo 2,4-dimethylhexane. Dashes are still used to separate word from a number, and comma are used to separate number from another number. No spaces in between the name of the class substituent and the parent chain. The classification here is tertiary because our reference is the halogen. It is being attached to this carbon atom, and that carbon atom has 3 other carbon atoms being attached on it. That's why it's tertiary. For this one, it's a fluorobenzene. This is the benzene ring, and that's the fluorine. Take note of the spelling, fluoro. This is classified as secondary because this is the reference, and this is being attached to that carbon atom in the benzene ring. However, that carbon atom is bonded to 2 other carbon atoms, so that makes it secondary.